And we are live.
Welcome, everyone. This is the August edition of the Toronto Permongers meeting. Dave Doyle is going to talk to us about Google Cloud.
Next.
18. Recap.
Yes. Is that you, Folko? Someone's making little noises. Anyway. All right. So for those that don't know, my name is Dave Doyle. I was fortunate enough to get a free pass and a free ride to Google Cloud Next about a month ago in San Francisco. So Google Cloud Next is the big conference that Google has been running now for the third time. So Google Cloud Next is basically how Google sells, oops, if someone can mute their microphone, please. Google Cloud Next is basically all kinds of talks around the Google Cloud Platform, which is, you know, Google's equivalent of AWS or Azure. Everyone says Azure, from what I can tell. I look at that word and I say Azure, but maybe that's because my mom is British. So, but it's based around their platform for, you know, compute, you know, virtualized platform for running your stuff. So, by the numbers, this is the third time that Google has run the event. It lasted 3 days, 4 days if you include the Partner Summit, which I also got to go to. Side note, don't go to the Partner Summit. It's all marketing.
Oh.
All marketing. Oh my God, it's all marketing. I was looking forward to some talks, and it was all marketing. Did I mention marketing? So for the rest of the 3 days, there were keynotes every morning. There were 36 tracks. So you actually had to plan out ahead. What you had to do is you would go into their little app or their website. You would choose ahead of time which things you wanted to go to and reserve your spot. If you did not reserve your spot, you would go into the standby line in front of the room, and you would wait until 5 minutes before. And everyone who had not been registered, because they scan your badge on the way in, then you could go into the talk. I can tell you, having looked at the schedule about 3 weeks ahead of time, all of the AI and ML talks were full, all of them. Now, granted, I was there because of my background in working in a Kubernetes containerized environment. I kind of focused on Kubernetes and scale and that sort of thing. That said, it was all different things, but we'll get to that. So there were 5,000 attendees on Monday, which were the partners. This is more than the total attendees of the first one. 3,000 of the attendees were Googlers. It was 25,000 people. It was simply enormous. I have never experienced it. The only conference I had attended before this was YAPC, now the Perl Conference. Well, formerly the Perl Conference, then YAPC. Well, no, the Perl Conference, OSCON, then YAPC got spun off, and now YAPC is the Perl Conference. So that was on average between 300 to 500 people any given year. That was my experience with conferences. 3, maybe 4 tracks. I think one year it was even 5. Certainly not 36. So it was rather overwhelming. Plotting out your schedule was literally hour and a half, 2 hours to make sure you got everything. So the conference space consisted of the Moscone West and Moscone South centers, the Metreon AMC Theater, the Yerba Buena Gardens, which was a public park that they completely blocked off, and all of the conference rooms in 2 hotels. So a local Uber driver had told me that no one has ever filled the entirety of one of the Moscone centers, never mind both, and then some. This was a massive event. I mean, there was 35 minutes between talks because that's how long it took to get to the next talk. Moscone West was 2 floors. South was 3. It was massive, and this is right downtown San Francisco, just off of Market Street. This was my first trip to San Francisco. That was also enlightening. Did I mention I like living in Toronto? I still like living in Toronto. So let's kind of jump into what the conference was about. There was a lot of bragging. So this is just a couple of the highlights for Google that they mentioned in their various keynotes about some of their big customers. HSBC is now using GCP for data analytics. They've got 100 petabytes of data and billions of transactions. The New York Times is using it to scan, encode, and preserve its entire historical photo archive. Now, as you can imagine, with the New York Times, that's a lot of data.
That's a big paper.
Yeah.
They've been in business for a long time.
Yeah. Target, this was a real coup for Google Cloud Platform because they got Target to switch over from AWS in its entirety to the Google Cloud Platform. Yeah. And Twitter has moved all of their large-scale Hadoop clusters to Google. 300 petabytes of data has been migrated.
Target thing is not wholly as expected. If you are a major retailer, running your stuff on the computing facility of a major online retailer is probably not a good idea.
Well, ironically, when they made the announcement about Target's big shift to GCP, Walmart announced a great big new partnership with Amazon and moving a heck of a lot more of their load onto AWS. Got to counter all the stuff coming up. There was a lot of stuff about the G Suite. I don't care. The G Suite being your Gmail, Docs, your equivalent of Microsoft Word and Excel and all that sort of thing. There were more integrations, things like Smart Compose in Gmail, where it basically kind of anticipates what you're trying to write and writes it for you, which is a little creepy. They also added a new real-time grammar checker, which is confusing. Why do you need that if it's writing your email for you? This was a big deal to them because they have it. They're really integrating the G Suite into more and more things, even into stuff where you can query their BigQuery databases directly from, like, I think a terminal inside Gmail for reasons beyond my comprehension. I may be wrong on that one, but there was a lot more integration there. That said, the G Suite was not what I was interested in, but they spent a lot of time pushing for this.
Is that one of the marketing things?
Well, the real key for this for them is integrating literally everything they have. They want the Google Cloud Platform integrated into every inch of their business. And G Suite has become a real moneymaker for them. My company, for example, uses them for, all the doc sharing and, hosting email. It used to be companies don't host their own email servers anymore. They start getting vendors, and now everyone's just using Google.
Yeah, I'm just surprised because, I think of the cloud stuff as being, the industrial machinery, and the G Suite is all the complicated applications, and that's a long way. Those two things are a long way removed from each other.
You'd think so, but they're not. Judging from the show floor, where all the vendors are, there was a hell of a lot of vendors that were literally touting various integrations into G Suite. Integrating databases, messaging, ticketing, every imaginable thing. They're integrating into G Suite. I don't know how effective this is. I am a developer, not a business person. I am not in marketing or product. So yeah, I have no idea if this is effective, because it's not something I would use or need. I need a terminal.
Yeah.
So another big thing, containers. Specifically Kubernetes, which is something Google created and is now out into its own. It's been spun out of Google, obviously, and it's part of the CNCF, the Cloud Native Computing Foundation. But containers are it. I'm sorry. I did a talk on Kubernetes here a few months back.
Thanks.
The reality is you can't miss this train. It's too late. Every company is moving stuff into the cloud. Everyone is doing containers. This is literally the new Steve Ballmer. It's not developers. It's containers. Containers have won. This doesn't mean that there's no use for on-prem or anything like that, but you can't get a job as a developer now without running into a company that has stuff running in Kubernetes or Mesos or some such home-rolled Kubernetes thing. Every service, like Google Cloud, they have the GKE, the Google Cloud Kubernetes engine. AWS has their own. Azure has theirs. And big companies I can't name who are my clients, but I can never name, and they're awesome and huge, and I really like working with them, are also doing this. So they've pushed into the Kubernetes space in GCP very heavily, which is to say they have their own host of Kubernetes, but there's a variety of other products that they're really pushing. Istio is a service mesh, which is kind of service discovery for when you're running microservices in the cloud. It's how do other things find it, kind of handling DNS and having a global service mesh. So it doesn't matter where you are, you can go here and you get that service. Istio just went 1.0. I have looked at Istio and service meshes. They confuse me, but everyone's using them now, so I got to do more research.
Service mesh. Meshes, what is that?
Mesh is combining basically self-awareness of services. You spin up a service in your cluster. The service mesh becomes aware of it via DNS records and advertises that to other things, so it can inform other components that this component is now live, and you can talk to it, and here's how you talk to it. You go to this endpoint. So it's really a way to, I think one way of putting it, one way of putting it is an alternative, I guess, would be Zookeeper out of the Apache ecosystem. It's basically a way to keep track of where all your services are, what's up, what's available, and how to get to it. They've also gone heavy on cloud build, which is, they don't talk about it as much, but this is using something called Spinnaker, which is a cloud native pipeline builder. Spinnaker in and of itself is not a CI/CD pipeline. But it gives you the components you can use to build it. And Google took that and they built an end-to-end CI/CD solution that is cloud native, which is running in a containerized environment. It can, you can push to Git, it'll pull it in, it'll build it, it'll test it, it'll send it to a staging environment, a QA environment, and then you can click to fire it up to production, or you can have that a completely automated flow. It all depends how you want to do it. I will say I did get to see a gentleman by the name of Kelsey Hightower speak. He's a dev advocate at Google. You may or may not have heard the name, but he's rather prolific, very big in the Kubernetes space. He has a nice little website or a nice little thing on GitHub on Kubernetes the hard way, basically how to spin up a Kubernetes, not using like the Google Kubernetes engine, but how, given an environment, how to spin up Kubernetes and build it, put it all together, all of the security issues, the DNS resolution within, the networking, and all that kind of thing. Now, his example all uses Google Cloud Platform. Now, if you are a reasonably intelligent person, which I am not, say someone like Mr. Sullivan here, who is familiar with systems, could probably figure out how to deploy that onto other things. The idea being it should not be restricted to GCP, but all the instructions are for GCP. So if you know how to allocate your own boxes in various other places, you can probably use it to spin up your own Kubernetes, and it's a good way to learn. And he was rather fascinating. He built a pipeline live on stage on a keynote. He's a very engaging speaker. I would suggest looking him up on YouTube.
Fascinating.
So, little interlude, San Francisco pro tip. If it's warm and you think you don't need a sweater, you do.
I mentioned that.
Yeah. This was a surprise to me. I knew it was a little milder climate in the summer than here. It's like 20 degrees Celsius every day. But even though it's like between the ocean and the bay on the other side and that, not very humid. And you walk from sunlight to shadow and you get really cold and the wind whips up out of nowhere. So yeah, you need a sweater. No matter what you think, bring a sweater. Everyone brings a sweater. All the locals laugh at all the non-locals because they can tell who
Everyone's wearing the sweaters.
Yes. I will also say about San Francisco, the richest part of the city and the poorest part of the city are butted up against each other, the Tenderloin and kind of the Market Street area. It's very odd to see the distance between the rich and the poor monetarily even bigger than Toronto. Physically, non-existent. The homeless are everywhere. This isn't saying, oh gosh, they should clean up the homeless. There's a lot of poor people. It's the West Coast. so people can survive the winters, but it's rather a shock. We have areas of the city where you have homeless, but this was on a whole nother level. Every store has a security guard or a cop standing out front. I saw a cop nudge a dude on the road to see if he was alive. I saw a woman shooting heroin on my walk back from the conference center. It's a very disturbing thing. It's also hard to tell tech workers from the homeless because they all wear the same shirts, because they all donate all of their swag shirts and the homeless get them. So it's very hard to tell sometimes. So one thing that really shocked me about Google Cloud Next was hybrid cloud. They want you on the Google Cloud platform. The Google Cloud is running third. AWS is number one. Azure, number two, with about 13%. Google Cloud has something like 5% of the market. They want you in. They want everyone in. And they will do anything to get you in. To the point where they have built their Google Kubernetes engine so you can run it on-prem or in another cloud. Further, they have created the Go Cloud project, which allows you to administer both on-prem and their cloud or someone else's cloud together in a unified interface. They demonstrated this on stage. They talked about integrating with Amazon. They actually said Amazon. I have never seen a vendor of this size mention their other major competitor, never mind show you how to integrate with them. They want you that bad to try their platform. They will do anything to get you on there. AI ML was obviously another huge push. In particular, they had Cloud Auto ML Vision, Auto ML Natural Language, and Auto ML Translation. These are new beta services. Yes?
I'm sorry to ask the obvious question. It's obviously ML?
Machine learning. I am not an expert on AI ML. Hey, Stuart. To me, what a lot of people say is AI and ML, to me, is very complex if statements. That said, what these ones are in particular, and what were fascinating to me, is these are ML models that you can extend to suit your needs and without requiring any specialized knowledge in machine learning or coding. So they have these systems that you can feed data to train the machine learning algorithms without having to know all about these things. Further, they have some massive BigQuery data sets that are open, all of Stack Overflow's comments, all of GitHub's repositories. They have that in a massive BigQuery table, which is Google's big data store, that you can feed directly into these models. One thing I found interesting, and we were shooting it around at work, like Auto ML translation. This is not about translating from one language to another. It's about translating anything from one to another. So ideas that came up about this: what if you fed it a paper, and you train the Auto ML translation module to make a synopsis for you, or you have a particular domain paper, marketing paper, development paper, architecture paper. You train a model to translate that into layperson's terms. It's really kind of fascinating what they can do. I really want them to take the Stack Overflow and GitHub and finally build a better version of TOB index, which is bullcrap if you've ever looked at their methodology, which is basically who searched for what. No, we're not going to distinguish between Python the snake and Python the language, but they've also got Kubernetes integration with Kubeflow. So this is running, I've already forgotten about this. It was basically about running AI ML flows right in a containerized environment. So the AI and ML tracks I didn't attend. Other gentlemen from my work did because he's in our applied AI team. But you couldn't get into them unless you registered about 2 months out for the talks. TensorFlow processing units. This is Google's, I'd say chips, but they're a bit bigger than that. This is their special processing units specifically built for AI ML. They just released the Cloud TPU Pod, which is a cluster of cloud TPUs. Scalable clusters, those are second gen. The new third version, which you see pictured here, of the TPU is 420 teraflops. So in comparison, the AWS P3 EC2 instance, which is their big AI ML workload instances, do 56 teraflops of processing. That's almost 8 times more. One of these TensorFlow TPUs can replace about 200 traditional rack servers, and it fits in traditional racks. You can see it has a fairly impressive liquid cooling system. Actually, one of my coworkers was able, just yesterday, he went to a special presentation from Google and got to touch it. They also showed us on stage one of the older TensorFlow chips, I think. It's literally 2 feet on a side. So that fits in a rack.
Yeah, it looks like the size is 19 inches. Well, I mean, whatever fits inside a 19-inch rack. Because I can see connectors on the 2 edges.
I don't pretend to know enough about this stuff. All that I can tell you is there was intense interest. I'm just a poor dev trying to build messaging systems. So, but it's rather impressive when you look at it. I mean, when you look at the biggest thing EC2 can do literally 1/8 of what one of these can do. And these things ain't cheap.
And they're building these at Google scale, so they put 100,000 of them in a building. Some unimaginable amount.
Well, that's the thing too. You can get instances based on these and get part of that. But they also have, like I said, the cloud TPU pods, which are clusters of these, which you can scale up and scale down as needed. Another interlude. This was breakfast. All meals were catered, or I should say breakfast and lunch were catered. What you're seeing here is buckets of hard-boiled eggs. I kid you not. There were a few glitches in the catering, shall we say. Breakfast was not great. But there was usually fruit and that kind of thing, but nothing resembling a meal. And they literally, you'll note, this is a table with holes, and these are just plain old white buckets that they literally were carting around, bringing out new buckets of hard-boiled eggs. There was unfortunately no place to crack the shells, so people are all banging them on heads, walls, tables, everywhere. It was rather insane, and you would find the cleaning staff actually did an impressive job because there was not eggshells everywhere. So there was a bit of problems with most of the logistics around food. At lunchtime, there would be, because this was also spread out, there were stations all over the place, but a station would get overwhelmed and run out immediately, and they'd send you down a floor or across the floor, and that would be out. There was no communication between anyone, so no one knew where to send you to get food. So I didn't get lunch most days. And for some reason, they have an obsession with aioli. Every sandwich had aioli on it. I don't mind aioli, but it was still weird. And for California, there was very little avocado. So these are some of the talks I saw, and I'll kind of touch on these ones, but I'm going a bit deeper than the other ones on some of the other ones. So building IoT on GCP. This was basically demonstrating Google Cloud's IoT platform. If you've looked at these ever, this is for connected devices. If you've looked at Google's or AWS, they are very sensor focused, which is where IoT kind of came into existence in big industry, oil industry, for monitoring sensors. My particular use case, because I'm working in this space, it also requires command and control, neither of which were really good for that. And neither platform will scale up to consumer scale. They're really good for smaller companies getting off the ground. I would think someone like Ecobee, for example, would actually still be too big to use one of these platforms because they're multi-tenant, but they're pushing it very hard. This talk, which I thought would be technical, was all marketing. I will mention that the talks I saw, there was not a single talk where a member of Google was not part of the presentation. Even if it was a third party presenting, Google was there. So I don't know if you are going to apply to give a talk at Google Cloud, you got to be partnered up with Google and deploying on Google, and you're going to need, at minimum, your account manager from Google on the stage with you. As mentioned, there were 36 tracks at any given time, so it was hard to figure out what would and would not be marketing, and it was hard to tell from some of the summaries. The next talk I saw I thought was going to be really cool. So it was how Bandai Namco Entertainment uses Cloud Spanner, which is an SQL solution in Google Cloud, and GCP's global network for high-octane gaming apps. As it turns out, high-octane gaming apps was Dragon Ball Legends mobile game, which is nifty. I'm not sure I'd call it high-octane. That said, they were using, what I was really interested in this talk was the global network, because that is also relevant to my interest since I'm looking at doing messaging on a global scale. They said, we use GCP's global network, but we're not going to talk much about that. They demonstrated that they could have really good latency of someone in Japan playing against someone in Europe or the US, which was cool, but I was hoping for a bit more meat on this one. Half of this presentation was given in Japanese and was translated because they actually had the Bandai Namco people in to give this talk. That said, their product manager gave us a 3-minute pitch on why we should play the game, and he said, we paid for this, so you're going to give me my 3 minutes, I'm sorry. So they did talk about how they used Cloud Spanner, which is an SQL solution, for storing all of the information related to the game, and usually most of it's user accounts. However, they didn't talk much about messaging, which would be really kind of key for a game that they want, as low a latency as possible on a global scale. So interesting, and I was in the room with developers from Bandai Namco, which was cool, but not what I was hoping for, unfortunately. So the next was hybrid and open surfaces with GCP, Envoy, and Istio.
I'm looking for the manager here. Somebody down there from Toronto Bureau.
Oh, yeah. Okay. So Envoy and Istio. Istio is the service mesh that I mentioned earlier, and what it's actually doing under the hood is using Envoy, which is something Lyft built, which is kind of a cloud-native HA proxy, we'll say. It's a proxy service, basically. But Istio uses it to build its service discovery. And it was this all came out of Lyft, who has some very interesting scale issues. It was interesting because they were using Istio and Envoy to build a service mesh, again, across a hybrid cloud. They had on-prem as well as Google Cloud Platform that they seamlessly handled through a single interface, which I thought was pretty cool. Best practices using Kubernetes, Spinnaker, and Istio to manage a multi-cloud environment. Again, they were going multi-cloud. Which is fascinating to me. Spinnaker is, again, the pipeline tool that I mentioned. This turned out to be, again, basically what this means, best practices. Best practice is to use Google Cloud Build, which is their nice little package system, so I didn't get as much out of it. It's built using Istio and Spinnaker and Kubernetes, but they have this nice little interface that handles all this for you, and it didn't go very much into the tech. The next one I saw was a good talk. It was called Fast IoT. This was given by the director of Google IoT, building systems that are responsive to the problem. So this was less tech and more strategy, and this is one of the more fascinating talks since I am in the IoT space sort of myself. So it's about what you need to do, and it was particularly interesting because devs are not very good at, you point them at a technical problem, they're very good at solving that problem. You point them at why they are solving that technical problem, not as good. So one thing this really encouraged people to do was take into account the perceived user experience of time to the user as more important than actual measurements. This is something devs are not very good at. We like to see, little numbers and reducing numbers without actually thinking of how that impacts people. So, for example, processing in parallel may require dynamic rebalancing of the workload mid-job. So doing this well means the cost of the rebalance is outweighed by the speed that it adds. So this is something where you get partial results perhaps back to the user instead of full results that take longer. Users have shown that they're willing to take what they can get rather than everything if they can get it sooner. Offline can be key, particularly in IoT. You can't always rely on network connections existing. Connections are cut, routers fail, routers decide to cut off connections. So store the data, reconcile later. Computation versus durability. Store things in memory, and if you can tolerate some loss of durability in data, you can really speed things up. If you're requiring like ACID transactions for every single piece of data, that's going to slow you down. And again, this comes into perceived speed. Optimize for impact, not pure performance. You can cut, your processing time down to 10 milliseconds. Great. But if that's over an 800 millisecond network connection, you've bought nothing. You've wasted your time optimizing something that didn't need optimization. You should have been looking at the network latency. I will talk about this one, but I've got the video in here, and I'll put a link to the group afterwards. This was my favorite talk, and it was literally the last talk that I went to on the last day and the last talk. So this was by an Indian company named Hike. They have a very popular chat app in India. They have 100 million users. As a point of comparison, BBM has 60 million users in India. So they are processing 1 billion messages a day and 300 million stickers. You can send people stickers an hour. I thought this was impressive at first until I broke down the numbers, and I've done better than that. But it was interesting because what this talk was, they took it from their initial architecture to the problems they ran into to what they chose to scale up, what they changed, what their platform now looks like on Google Cloud Platform, and what their future plans are. They went through 4 different data stores. They started with MySQL. They moved to, I can't remember, maybe it was Postgres, and then HBase, and then to BigQuery on GCP. Interestingly, they are using MQTT under the hood, which is, again, something I know a lot about now. Didn't a year ago, but I do now. MQTT is a very small messaging protocol, binary in nature, payload agnostic. It came out of the oil industry and IBM. It's popular in IoT because the client is very small, the messages are very small. You can have different levels of quality of service. 0 is fire and forget. You don't care if you fire out the message, and if someone gets it, great. If not, oh well. Quality of service 1 means subscribers to that topic will get the message at least once. Quality of service 2 means they will get it exactly once. So a lot of, in messaging, I found a lot of people are operating on the QoS 1 level, which is they want to know that their clients got the message. So the fire and forget is out. But QoS 2 adds a lot of extra overhead to make sure they get it exactly once. And there are parts of the message anyway at QoS 1 to tell whether this is a duplicate send or how many versions of the message have been sent.
I imagine the receiver would say, I just got a message. Let's look at the ID or the hash or whatever. Yeah, I've seen this one already.
That kind of thing. It adds more load on the device, but it's a relatively small amount of load because usually these devices are constrained. They don't have a lot of processing power. So you got to keep these things small, but QoS 1 is kind of the nice balance. Google Cloud has its own messaging service, MQTT, Google Cloud Messaging. They didn't use it. I asked them because they never mentioned what their MQTT broker was, and that is very relevant to my interests. So I got up at the end to ask, hey, what MQTT broker are you using? And they treated me like an idiot, or at least maybe they just misunderstood and said, MQTT is a specialized protocol for messaging. Yeah, but what broker? And then they moved on to the next question. So I used the magic of the internet afterwards to reach out to them on LinkedIn, because the world is a wonderful place and you can look people up that way. And I said, hi, my name is Dave. I am the guy that asked that question. I'm really curious. I saw your blog posts on your architecture, because they actually have some fascinating blog posts on architecture. And I asked, what MQTT broker did you use? We wrote our own. We based it on a very simple Java implementation and extended it. Now, I'm doing a side project right now where I'm using a rather boutique language called Crystal. Crystal is Ruby with strong typing and concurrency. So it's something I was playing around with. So I'm writing my own MQTT client and server in Crystal for fun to help me learn the language. I know that writing an MQTT server is not complicated. Writing a clustered broker is complicated. You have to implement some kind of sharing. In Erlang, for example, you get a whole advantage with the Erlang OTP layer, which will handle all the synchronization. It has its own consensus algorithm. Most companies will use, most things out there these days use Raft or Paxos consensus algorithms. So they obviously did something like that because they've had to scale that horizontally. You can scale MQTT servers vertically to some degree, but a lot of the problems in MQTT servers is around setting up the queue for new subscriptions. If every new person has its own subscription for its own unique message stream, that takes a toll on an MQTT server. Trust me when I say I know this. We'll see if I get accepted to KubeCon Seattle, in which case I'll be able to tell you all about the fun I had with that, as well as who my client is. So go me. I'll find out in 2 weeks if I get into KubeCon Seattle. Got turned down for Shanghai, unfortunately. We also applied to KubeCon Shanghai. But the executive VP of the CNCFs told me to apply to Barcelona. So I take that as a good sign when the man who rejected my paper told me to go and apply to this other one.
Yeah.
And I've never been to Barcelona, so that would be great. So I would really recommend this video, if for no other reason, because Hike presented, I mean, India gets a lot of flack for outsourcing and such. These guys built something from nothing, and really impressively so. And I thought it was literally the best talk I saw there. If any of you are regular attendees of YAPC, about, I think it was Columbus, maybe 7, 8 years ago or something, I've forgotten his name, the Game Crafter website, Madison Perlmunger's head, I can't remember his name. The Game Crafter is a website that lets you craft your own board game. You get the templates for the boards, the cards, and all that sort of thing, add your art, you order the pieces you want, you click go, and they have a whole process of how they will print it, assemble it, box it, ship it. So a lot of companies are now using them for prototyping. That is probably on YouTube as well. I would very much recommend it because they had interesting challenges as well. Some of the best talks I think you can ever see are saying, here's what we wanted to do. Here's all the things that happened when we tried to get there. Here's what we did to mitigate it. And that's what this talk is really about. The problems they encountered with scaling their messaging, with scaling their user queue, with scaling, you know, processing all the information that goes through the system. So they had a lot of worker queues, handling a lot of information. It is one of the best talks I've ever seen in terms of going through things and here's what we did, here's where we are now, and here's where we're going. It was a really, really fascinating talk.
There's a lot of meat in this talk.
It was literally one of the best talks I've ever seen. So kudos to them. I begged them to do a blog post on their MQTT broker. And they said, well, it's proprietary. I know, but tell us some stuff, man. It's good stuff. So hopefully they'll get that out. And I have a new connection on LinkedIn. So yeah.
Excellent.
Mm-hmm.
I got a question, Dave.
Yeah.
Back to MQTT mode 1, where you're guaranteed delivery of 1 or more copies of the same message.
Right.
How do people handle deduping of the messages that they then receive?
They'll have the same message ID, but they'll also have a dup flag set. So this is a flag sending that the server, the broker, has sent it out again. There's also, I believe, you can also use versioning. So it's really incumbent on the client to decide whether to act on the message or not. So they do have a unique identifier. You just have to be aware that you can't make it a simple dumb system. You have to keep track of which messages you have seen and responded to appropriately, and then make duplicates of that message that may come in a no-all.
So you got to have sort of like a time-based scoreboard to make sure that you can check which ones you've already received,
No.
and eventually start ignoring the sequence numbers.
Not time-based. A, because MQTT can send multiple messages in parallel unless you tell the broker to reduce the stream to one message at a time, which gives you time order integrity, but greatly decreases your throughput. So there is a unique ID assigned by the server that remains static. Even if it's sent out again, it remains static. So you have an ID, which is literally a monotonically increasing integer. So you just keep track of which message IDs you have seen.
You know, that could be a really, really big number.
It could be. But you can also, there's mitigations for that. For example, I would recommend taking a look at the PAHO MQTT client. They have implemented an MQTT client in multiple languages, Go, Java, Python, and they have mitigations in there for how they do it. They have kind of a cache of last seen messages, and it's got a time to live, so it'll discard it over time, because you're not going to get it, you know, hours later, presumably.
Right, that's sort of what I meant by a time-based scoreboard.
Okay, sorry, I thought you meant like in the message.
Yeah, okay.
Yeah, you can do like a time to live type of thing, time-based stuff.
Okay, thanks.
Woohoo. Interlude. So I mentioned this before we started broadcasting. There was a gentleman that I worked at with another company that I never knew, but we worked together, and he is now at the New York Times and was at Google Cloud Platform. And through a mutual friend, he posted this picture and said, yeah, it was massive. This is the second floor of, I think this is Moscone West Center. And he said, it was massive. And then I noticed this little cyan blotch. You can't see it here, but when I zoomed in, I've got a cyan shirt on, and it looks like it says connected on the shirt, which is the name of my company. And then I noticed this gentleman was wearing glasses and had kind of the Reed Richards silvery hair at the sides. It's me. So he doesn't know me. He doesn't know what I look like, but he took a picture of me, and a mutual friend got it at a place where there are 25,000 attendees, not including all of the support staff. So I was just fascinated with that. So in conclusion, I would say the takeaways from this, one thing I didn't talk much about is get on the show floor, talk to the vendors. You can get FaceTime with developers of the tools you use. I spoke to the people at Nginx, Signal Effects and Datadog for monitoring. I spoke to some interesting guys in different databases, FaunaDB, which is kind of a Cassandra-like database, but with ACID transactions and much better querying. Yugabyte, which is another cloud-native database, which has some similar kind of RDBMS features in a NoSQL store. I got to talk to DDN, which is a storage company that bought a division of Intel that was previously a small company named Wham Cloud that I used to work for. And they had no idea what I was talking about when I went to talk about high-performance computing, which was hilarious to me because the board, when it was Wham Cloud, was composed primarily of DDN executives. I got to talk to HashiCorp, who are very big in the container world. I got to speak to Equinix, global networking company, hosting company, where they run their own backbones. Even our old company used to use them. One of my old companies used to use them. So it was really fascinating, and it wasn't just marketing people. There were developers on the floor, and I got to talk to them about real problems that I had, and oh my God, can we do that? It's turned into some interesting relationships and some also very aggressive marketing. I will tell you, everyone had a badge with an RFID chip in it. So when you went up to a vendor, they scanned you. It told you who you were, what your email address is, and your phone number, which I did not realize at the time. So while I was still at the conference, I was getting phone calls from Boston, Oregon, San Francisco, San Mateo. I'm like, what the hell is going on? Because I was in the US and I didn't want to, take the calls and get charged. I found out later MongoDB was calling me literally twice a day. And I am, to this day, getting an email every day, a month later, from MongoDB, like, hey man, let's talk about your use case, man. So it was interesting. That said, I also got to meet a company named Solace, based out of Ottawa. They do their own proprietary MQTT broker. They also do their own messaging hardware. They have appliances that function as MQTT brokers that are optimized specifically for messaging, which is fascinating. They got some very big clients, like the entire Singapore transit system uses them. Mercedes-Benz uses them. And so they're this big, and when I looked further into it, because I'm implementing my own MQTT client, I've been digging very much into the spec docs of the protocol, which are hosted on Oasis. They're an Oasis standard. And I looked at the contributors. Well, goddamn, 2 of them are from Solus. Interesting name for a company. Doesn't really say, I don't know. Solus doesn't really say messaging to me.
SOLUS?
SOLACE.
Oh, Solus.
As it quantum solace, yes. But I was thinking more like funeral. Anyway, but that said, they are very interesting people, and they have some people in Toronto, and they're gonna come and talk to me and give me a demo, which is pretty cool.
Wow.
I've also had a demo from FaunaDB, SignalFX, Datadog. So a really interesting way to actually connect with these people. All the more fun when you get to tell them, I have a very big client who I can't tell you who they are, but I'd like to talk to you. They try very hard to find out who your client is. It's quite funny. So it was useful. It was fun. I skipped out on a talk or two so I could spend more time on the floor. I did not appreciate how interesting it could be. There's certainly lots of marketing folk. And I did get 5 free t-shirts. Whereas one of the fellows on my team that came down got 16. It was very impressive. He hit up every booth. So getting FaceTime with actual developers is really fascinating. Particularly to me, I spent time with, like I said, Nginx. HashiCorp, I spent a lot of time talking to them. They do Terraform, which is declarative infrastructure. So basically, it's a way to script how you spin up cloud resources like AWS or GCP. It's kind of if you've heard of Ansible or Chef or Puppet, it's the equivalent of that, but for infrastructure.
MQTT stands for message queue.
Transport something, I don't know. Actually, MQ is not message queue. I can't remember what it is. Telemetry transport is the last 2, but MQ was, I can't even remember now. The docs are rather, or I should say the specification is, I'm not used to reading spec things. I'm not used to having to implement things myself, but this was part of an experience for me to try and do that. So it's very interesting. To be a server, you must do all of these things. You may also do these things. You should do this, which is kind of passive aggressive in my opinion, how they write that. Also, there is, I know, I hate it. That said, all of these specifications, I wish someone said, hey, can you give me a client that would test all of the things that a server should do, and a dummy server that would test all of the things a client should do to validate that it does the right thing? That doesn't exist. So I might write that, because that's also entertaining. I also am looking at implementing the Raft consensus algorithm in Crystal because I'm an idiot. So I've been reading papers and that sort of thing, getting my head around this stuff, because I don't know. I hit middle age and I decided I'm going to punish myself further. I bought a dog, I had kids, you know, the whole 9 yards. Now I'll start reading, you know, RFCs and that sort of thing. Ironically, I saw a dude there, he was the most hipstery hipster that I ever hipstered. He had a pipe that, I shit you not, was 2 feet long, and a bowl that was maybe 1.5 centimeters wide. It was the fanciest ass pipe I ever saw in my life. It was like the opposite of Popeye. This was a little addendum in the Fast IoT talk. the director of Google IoT gave a little talk on time and relative values of time, and I thought it was fascinating just conceptually to look at different layers of time. So like less than 1 nanosecond is the time between a clock cycle of a 3 gigahertz CPU, or it is the delay between the frequency oscillation for a 2.4 gigahertz Wi-Fi radio. 125 nanoseconds is the delay between clock cycles on an 8 megahertz microcontroller. 20 milliseconds is the PWM frequency for a servo. 50 milliseconds, latency to the near cloud region, time for a touch on your big toe to reach your brain, and 50 milliseconds is all it needs for your brain to detect audio being out of sync with someone's lips moving.
Wow.
That's a remarkably low amount of time. I found that fascinating. The time for the touch of your big toe to get to your brain is the same as the amount of time for your brain to figure out that the audio and video are not synced up properly. I'm going to go back and watch Godzilla.
And stub your toe at the same time.
Yes. So 250 milliseconds is the latency to the far cloud region, a quarter of a second, and how long it takes to blink your eye. 1 to 3 seconds is the time that is required to plan a query in Google's BigQuery, which is to say, you provide a query to BigQuery and it builds the plan to run the query, and it takes 1 to 3 seconds. This sounds very slow, but BigQuery usually runs on massive data sets. 1 hour is the duration of a slack tide, which he defined as the delay as the tide sloshes in and out. I don't fully understand that, which is embarrassing because I was born on the East Coast. And 1 month is how long it takes a strawberry to go from flower to fruit. So all these different layers of time are rather fascinating to me. And all of this is related back to a user's perception of time. This comes into play in airports as well, if you've ever heard this one. There's active waiting and inactive waiting. You may note when you get off an airplane and you have to go collect your bags, it's quite a walk. This is intentional. They actually build this into the airport because they know how long it takes them to get the bag out. But you know what? If you're walking, you're not standing getting angry that your bag's not there. They intentionally add loops, add distance to this walk to make you spend more time active rather than standing inactive at the baggage claim. And the perceived experience is you get to your baggage claim and you may spend 1 to 5 minutes waiting for them to start coming out. But if they gave you the direct route, you'd spend 10 to 15 to 20 minutes standing there. And that ticks people off. So people's perception and experience of time is so important in not just IoT, but in software, in products, in entertainment.
He mentioned a half a second.
He did not.
Because that's apparent. IBM did some research, I think in the 70s, early 80s, of online system delay. They discovered that a half a second was the watershed between instantaneous and perceived delay.
That's interesting because on the project I'm working at, I am required to run at subhuman notice latency, which they defined as 250 milliseconds, a quarter of a second, not half a second. So if you are issuing a command from a phone to a device, they want that to have gone up to the internet and back down to the device and have it take action in less than a quarter of a second. Now there's ways to mitigate that. But it's really fascinating because of the nature. I'm working with a consumer electronics company. So these things are really top of mind for them, the user experience. And I really, really hope I get to tell you who I'm working for because it's so exciting. Have I mentioned I'm a big child? I turned 42 this year, so I'm waiting to discover the meaning of life. So those two talks, the fast IoT talk and the billion messages a day talk from Hike, were, I always find when I go to conferences, it's not about what I learned there, it's about what I want to learn when I leave. And these were rather mind-expanding talks for me. One had nothing to do with actual code, but it really changed how I looked at what I was doing. And the other is just fascinating from a systems perspective to see the evolution of a system. What were your problems? How did you mitigate them? And it's never a straight line. You try something and that fails. You try another and that, oh, that one gets you further ahead. Having to work on a system that's supposed to work at scale, it's punishing. And this will be part of my talk, but you get through this barrier and you're like, yes, and literally 5 seconds later, you hit the next barrier. I can tell you one, for example. In Kubernetes, you have this abstraction called a service. When you have a cluster of something, like you have a clustered message broker that has many instances, or Cassandra, a data store that has many instances, you can group them under a service. The service provides a DNS entry within Kubernetes where it basically serves as a round robin load balancer. But it means you have a single static address that you can get to the service. That interface is natted. Maximum 65,000 connections.
Oh.
Oops. So that was one of my very first things, because I was supposed to scale into the millions, and I hit a blocker at 65,000, which was extremely frustrating. So I couldn't use that abstraction. So I had to remove the service thing and build a whole lot of extra tooling into Kubernetes. And I have, HA proxy looking at everything and spreading it out over that. And then I found, oh, actually, I could have added one line to the service and make it headless, which is a term I don't understand in that particular context because there ain't no monitor. That would basically get rid of the natted interface and spread it out more so I don't hit that 65K limit. So one line would have saved me quite a bit of tooling, but hey, Levy.
I'd like to interrupt with my comment on response time.
Yeah.
One of the troubles with attending Perlmongers remotely is there's never a good time to interrupt, and the speaker usually keeps on talking, so there's never a pause to jump in with.
I am obnoxious that way.
But having said that, it was a good thing that you had your little segue about you just turned 42. My comment was my first project, which was 39 years ago, was for Air Canada. And their requirement was that from the time they hit the enter key on a terminal anywhere in the world to the time the first line of a message came back from the host had to occur 90% of the time in less than 1 second. Over a 2400 baud link. So that included the transmission to and from anywhere in the world to Manitoba, where the host was, and back, and look it up and get back to the other side of the world.
Good God, wait a minute. What was the network latency on a connection like that in the first place?
Well, you can just imagine.
No, I can't.
And that's on a shared line where you had a few hundred terminals all sending their requests and responses down that same 2400 baud link.
2400 baud 39 years ago?
Yep.
You were fancy, man. My first was 300 baud.
Well, we're talking commercial here.
I know, you fancy ass mother. Anyway.
But that was 39 years ago. But
yeah.
Then we did another thing for Air Canada later on, probably about 10 years or so ago. That requirement had changed. It was now they expected, I don't know, something like 20% of the responses to have happened within 10 seconds over equivalent of like T1 speeds.
Wait, they 10 times their response limit?
Over, 100 times the bandwidth.
Why did it go up?
That's a very good question, because they were now doing so much stuff that they didn't need to do that was the only kind of response time that they could realistically expect now.
Okay.
And it was tough to achieve.
Yeah, I do hope then you haven't worked on their mobile app, considering they just leaked 20,000 users' personal details.
No. Well, I've been out of the business now for a little bit, and they've gone to other vendors, so I don't know what's going on now.
Well, apparently,
I hate to imagine.
Oh, one thing I did forget to mention there in the conclusion. As mentioned, it was pretty marketing focused. That's frustrating. I'm hoping I get a chance to attend Kubernetes Con, regardless of whether I get to speak or not. But it's very hard when literally every talk had to go through the Google filter. All the more impressive because, as I mentioned, it was 36 tracks. A lot of the talks were just Google people. Maybe half the talks had outside people. And it was very focused on, major big name partners. But as I mentioned at the beginning, they want you on Google Cloud Platform. They are third in the cloud and adoption. If you want to just do lift and shift, which is to say, take your stuff from on-prem and move it to the cloud, that's the most unglamorous work, but they'll take you. They'll help you. You want to do multi-cloud, you want to combine their cloud with Amazon, they'll take you. They'll help you. You want to do stuff on-prem or combine it with their cloud, they'll do that. They are pulling out all the stops. And I can tell you with the size of this conference cost millions. I mean, they closed a public park. That really ticked off the locals. They took over both Moscone convention centers, 2 hotels, a theater. It was incredible. They had a member of Salt and Pepper come and do a set. They had a DJ on stage that was mixing tracks with her sister in New York, live. So it was really quite a fascinating experience, but if you can't deal with marketing, this is not for you. That said, you have access to Google people like you've never seen. You can walk into a lounge and talk to the director of Google IoT, the director of Google Cloud, Diane Bryant, the head of Google Cloud, made herself available to people. That said, people probably got fired for this conference. Their keynotes didn't start on time and ran over time and interfered with various other things. It was not good. I was very fortunate because I had a nice little Google partner badge, which meant I got slightly better access to things. It did not go well for some people. I wish I had remembered to add the picture of the keynote. The main room where the keynote was delivered had 5 screens across its width, separated by, 50 feet. Each of these screens were almost the size of a small movie theater screen. This room was the size of an airplane hangar. It was enormous. It was stunning. I have never been in a covered, I have been in stadiums that are smaller than this. It was truly shocking the scale at which they were operating.
All the better to read your email with.
Oh, all my emails already on Google anyway. They promised not to read it. They swore. But yeah, a lot of this stuff, I would recommend searching for Google Cloud Next on YouTube. They've posted most of the talks. As mentioned, my favorite talk is right here. I highly recommend it. For me, these kind of talks are just the best. What we did, where we are now, what we're going to do is such a fascinating journey for any company and any product and any system. You're sure to get something from it. But that's about all I got. How long have I been rambling on? Wow, not bad. Oh, I'm sorry, Boozer. I just realized I could have helped get a Boozer up here. But yes, that's about it for me.
Great.
If anybody's interested in the Doyle conference, they've got a YouTube channel, and this year the stuff was pretty good. The video presentation quality.
The video presentation quality.
Yes. In other words, in general, you could hear the audio and the fairly consistent shot of the projector, shot of the presenter, and a shot of the screen that they're waiting at.
Usually they were standing in front of the screen at GCP because they were all huge. But yeah.
I mean, it took a couple of years for the people some of the early ones were fairly awful, but they improved considerably since
Okay, well, thanks, Dave. That was
All right.
fascinating. I think I have some reading to do.
So do I. Holy.
I don't want to do any future. Want to do any future software development in the field. So I just turned my camera back on. I don't know if I'm broadcasting to the group.
You are.
So September is typically the Lightning Talks presentation. So I will put out to the list that we're looking for Lightning Talks and find out if I get any takers. And if there are no takers, then I'll see if I can find a regular talk. Anyway, we'll see how that goes.
What is the date of the next meeting?
That's a good question. Let me see if my whole browser has enough guts. Oh, it seems to be a little faster.
September 27th.
It sounds good.
Well, damn.
Anyway,
My company recently rebranded, and my client will be in town on that day for a party for that said rebranding.
wow.
So I will sadly. Did I mention this is why I passed off
Yes.
duties for these sorts of things?
Yeah.
All right. Well,
right,
I'll
well,
stop the broadcast now. So everyone, send Alex an email and volunteer for a lightning talk. It's a great way to get experience speaking, and you don't need to be an expert. You just have to be enthusiastic.
That's right.
Thanks, Dave. Night.
Good night.